Hello everyone. This session I will cover agglomerative clustering. All of you know the objective of the clustering. The primary objective of clustering is to cluster analysis. The primary objective of clustering is cluster analysis. It's an exploratory method for identifying the homogeneous groups of records. And also you know that similar record should belongs to the same cluster and dissimilar record should belongs to the different cluster, right? All are clear with the objective of the clustering. In the previous session, already we have covered the k-means clustering, right? So actually there are two types of clustering algorithms. One is the hierarchical method, right? And another one is the non-hierarchical method. So in the previous session, means in the lab session, we have already implemented the assignment using the k-means clustering technique. So you know that what is k-means clustering technique, how it is used to form the groups of clusters. So here in the non-hierarchical methods, predefined or pre-specified number of clusters assign records to each of the cluster. And it requires specifying this number of clusters, but it is computationally cheap. All of you know how to form the groups or clusters from the set of objects using k-means clustering technique. Actually, k-means clustering technique is the partitioning techniques, right? And another type of technique is hierarchical method. So here is the example. Here agglomerative clustering is the example of the hierarchical method. So in this agglomerative clustering, we begin with the n clusters. Sequentially, we merge similar clusters until one cluster is left. How your agglomerative cluster works here, we can discuss. Here is the one example given, right? We start with the each and every point in the data set belongs to the single cluster. Here, for example, my data set includes the 6 objects A, B, C, D, E, and F. So in the first iteration of the clustering, we form the 6 different clusters and every cluster have only single object, right? Then in every next iteration, we merge these objects together. We merge the clusters, right, to form the new set of clusters. So for example, here in the second iteration, the object B and C are merged together. So for merging these clusters, here instead of calling the object, we call the cluster, because here in the every iteration we merge the clusters to form this new set of cluster. So here also we have said that in first iteration, all the individual data points are representing the cluster of the single object, right? So in the second iteration, we have merged these two clusters, B and C. So definitely we need some merging criteria to merge these clusters. So what are these different merging criteria that we have to discuss in the same session in the next slides, right? And also in the second iteration, the D and E objects or clusters are merged together. Then in the third iteration, DEF means D and F clusters are merged together. Then in the fourth iteration, my BC cluster and DEF clusters are merged together. And in the last iteration, we form the cluster, a single cluster of all the objects. So if you observe here, all the objects are grouped into the single cluster. So here you can note down sequentially, we merge the similar clusters until the one cluster is left. So this is the idea behind the agglomerative clustering. So when it is useful when goal is to arrange the cluster into the natural hierarchy and require specifying distance measure. Here, unlike the k-means clustering, we not required to mention the number of clusters, the initial number of clusters. Here, step by step, we merge the clusters to form the new set of clusters. So here also we identify some cutting point to to decide the set of clusters, and as per your application requirement, you can take the one set of the cluster from one of the iterations from the dendrogram for solving your problem. I hope students you are clear with the idea behind this agglomerative cluster. So some are the basic terms that we will cover here, that is you need to understand for this hierarchical clustering. So dendrogram is the graphical graph. A dendrogram is the graph, right, that we use to represent the or summarize the clustering process. Which clustering process? That is hierarchical clustering process. So dendrogram is a tree-like diagram that summarizes the clustering process. Also, we represent the clusters of the partitioning method using the scatter plot. But here we use the dendrogram, which is tree-like diagram, to summarize the clustering process, right? And the similar record joined by the links in this method, in the hierarchical method, similar records are joined by the links in this dendrogram. So with example, I will explain you how these similar records are merged together by using the different merging criteria, right? So one of the merging criteria you can select to solve the problem here. Then record location determined by the similarity to other records. So definitely here also we require one distance matrix. One of the distance matrix you can use to find the distance between the cluster here or objects into the clusters. So this diagram shows actually the dendrogram. How to draw this dendrogram from the given set of data points for your problem, I will explain with example in the coming session. Right, so in this session, I will cover what different merging criteria you can use to form the clusters or to merge the cluster in every iteration. So in the dendrogram diagram here, dendrogram, here this represents the distance, right? So in the merging criteria, also we consider the distance of these different levels, right? Then these links are used to merge the clusters, right? As per one of the merging criteria, right? So with example, I will explain you how to draw this dendrogram. So in the hierarchical clustering algorithm, we start with the n cluster as we discussed in the first slide here. We start with the n cluster. My n represent here number of data points in the data set and one record in each cluster, right? Then step one is two closest records are merged into the one cluster. Now, how you will find the two closest records? So you will apply some merging criteria here, right? So that we will discuss in the next slide. Then at every step, pair of records or pair of cluster. Here again, I am repeating, student. Here we do not calculate the distance between the object, but here we calculate the distance between the clusters. And the clusters, those are more closest, right? The clusters, those are more closer. In that iteration, we merge together. So here at every step, pair of clusters with smallest distance are merged. So what can happen in that merging process? Two records can be merged, or single record added to an existing cluster, or two existing clusters can be combined. So when we will discuss the solution, we'll understand in the merging criteria, one of the case can be there. So definitely it requires the definition of distance. So distance, for calculating the distance, you can use Euclidean distance method or Manhattan distance method or any other method. So also you know the different properties of the distance. So pairwise distance between the records is represented by Dij is equal to distance between the records I and j. Distance requirements, you know these properties. These are the non-negative. Distance should be non-negative. Dij should be greater than 0, right? And the distance between the object I with itself will be 0, right? Then another property is symmetry property, Dij equal to Dji, and triangular inequality property. So here you assume there is a university data set, UG Business Program University data set. So data for 25 undergraduate programs at business school in US universities in 1995. So this data set contains what? This is my numerical data of 25 universities, right? And here are total 6 attributes, right? So these are the columns in the data set: SAT, top 10, accept, ratio, expenses, and grad rate, right? So just we will see here what how you can form the clusters of this data set. So distance between the two universities. So there are two universities, X and XJ, for example, Caltech and Cornell. So Caltech and Cornell, these are the two universities. So you know that how to calculate the distance between these two objects. These are the two objects. So you can use here Euclidean distance. And these are the five different values that will represent this object. That is university objects, right? So these values are taken from this data set. So here is the Caltech, and here is the Cornell. So these are the five different values. So you apply here Euclidean distance formula to calculate the distance between the two objects. Here my object is nothing but the university, and it is represented by the 6-dimensional data set. 6 dimensions are there. Just to revise the Euclidean distance formula, I have covered here that example, right? Now how you calculate the distance between the cluster. So here, actually Euclidean distance is also required in this technique to calculate the distance between the two clusters. So how we calculate this distance? By applying some criteria, merging criteria. So first criteria is the single linkage criteria. So here, this session, I will discuss the 4 different criteria for merging the cluster. So first one is the single linkage, which is also called as the nearest neighbor method of calculating the distance between the two clusters, right? So we are calculating distance between the clusters here. So distance between two clusters is equal to here minimum distance between the members of the two clusters. So what distance we consider for the distance between the two clusters? So here we calculate the minimum distance between the members of the two clusters. So see, there are two clusters here. This is my one cluster and this is my second cluster. So my first cluster is represented by the blue point, second cluster is represented by the red point. So nearest neighbor is the minimum distance between these two clusters we consider as the distance between the two clusters. So these are the set of points, but if we calculate the distance of each point from each point of the other cluster, so the minimum distance will be this, as shown by the green line here. Okay, so this distance between the minimum distance between the members of the two cluster is nothing but the distance between the two cluster here. So which is the nearest neighbor single linkage criteria for calculating the distance between the two clusters. I hope students you are clear with this. So here what you will do, here you will use the formula, you will calculate the distance of every point in this cluster from the distance of each and every point from the other cluster, and you will take the minimum distance. So this will be the minimum distance between these two clusters. So these two members will give you the minimum distance, and that will be the distance between the two clusters using the single linkage criteria. Another method for calculating the distance between the cluster is what? Complete linkage. So in the complete linkage, this is reverse of the single linkage. Here we consider the farthest neighbor to calculate the distance between the cluster. So here in this method, the distance between two clusters is equal to greatest distance between the members of the two clusters. So if you calculate the distance of each and every point in this cluster from the each and every point of this cluster, then the farthest distance, right, largest distance will be between these two objects, this one and this one, as shown by the green line here. Right? So you will take here the minimum of all these distances. So sorry, not minimum, maximum of all these distances. So maximum distance will be given by these two objects. So that will be the distance between the two clusters using the complete linkage criteria. I hope students you are clear with this. So here we use the max formula. In the single linkage, we use the minimum formula, right? So we take the minimum distance, here we take the maximum distance. The next method is the average linkage. In the average linkage method, right, the distance between the two clusters is equal to average of all the distances between the members of the two clusters. The distance between the two clusters is equal to the average of all the distances between the members of the two clusters. So calculate the distance of all the members of this cluster from the members of this cluster, another cluster, and take the average of all these distances, right? So this is the third method of calculating the distance between the cluster using average linkage method. And fourth method is centroid linkage method. Fourth method is the centroid linkage method. Here the distance between two clusters is equal to distance between their centroids, distance between their center points. So first calculate the centroid of this cluster, then calculate the centroid of the second cluster and calculate the distance between this centroid. This will represent the distance between these two clusters, blue and red here. I hope, students, you are clear with these methods of calculating the distance between the two clusters. So if you summarize these methods, pairwise distance between clusters, then there is a single linkage method which is called as the nearest neighbor method. Minimum distance between the members of the two clusters are considered. Here in the complete linkage method, the farthest neighbor, that is greatest distance between the members of the two clusters are considered. In the average linkage method, average of all the distance between the members of the two clusters are considered. And in the centroid linkage method, distance between their centroids are considered. So now how this hierarchical method works, we have already covered here the different criteria, merging criteria that we can use for merging the cluster in the every iteration. So here we start with the n cluster. So each record belongs to the one cluster here. Here record is equal to the one cluster because it is a initial iteration, first iteration. Then in this step 1, two closest records are merged into one cluster by applying either single linkage, complete linkage, or centroid or average method. Then at every step, pair of clusters with smallest distance are merged. So if my method is a single linkage method, then we use the smallest distance merge method. So these are the three possibilities that we discuss also. Two records are merged, or single records added to an existing cluster, or two existing clusters are combined together, right? So here is the one example, just showing the dendrogram for the hierarchical clustering technique. So here in the hierarchical technique, in dendrogram, height of the branch denotes the distance between the entities that are getting merged at that level. Right, so that I will explain you with one example, numerical example. Definitely you will clear with this concept. So here just I want to show you the graphical representation of the clusters that is formed for the university data set. So if you are using single linkage method, right? So your dendrogram will be like this. So how this dendrogram be obtained from this given data set, that I will explain with numerical example in the next session, right? So here this dendrogram, this represents the distance level, right? And this represents what the set of clusters, right? So in every iteration, we apply some merging criteria to merge these clusters. And in the last iteration, you will get all the data points into the single cluster. Then this is the dendrogram using complete linkage method, right? So the representation, if you observe, some difference is there. So definitely because my criteria of merging is different here. So after dendrogram is obtained, cut it to create the cluster. So you can decide one cutting point. Here is the one cutting point. So if my cutting point is here, so as per your application requirement, if your application required the 3 clusters, 4 clusters, right? For example, if you take the example of the pizza center, so initially you required only 2 clusters, right? Because you want to open only 2 different centers for giving this or servicing the pizza, right? So depending on the application requirement, you can set your cutting point here. So if your cutting point here, so you will get here 2 clusters. One cluster will be this, second will be this. If your cutting point is here, then you will get here 4 different clusters. 1, 2, 3, and 4, and so on. So like this, you can decide your cutting point. Cutting point determines the number of cluster and obtains on resulting clusters. So for your application, right? I hope student you are clear with the basics of the hierarchical clustering technique, right? And in the next session, I will cover the numerical example for the different merging criteria, right? So here K-means is the example of non-hierarchical clustering that already we have discussed in the lab sessions, right? And also you have implemented one application using the K-means clustering. So these are the set of steps these are some points in the K-means clustering and the steps in the K-means clustering algorithm, right? So I hope student you are clear with this. Thank you. Here you can just note down the difference between the K-means and hierarchical. The good is computationally fast for large data set here and useful when certain K is needed. Here it finds a natural grouping, no need to specify number of clusters, and Dendrogram transparency of the process, good for the presentation, right? So I hope you are clear with this. Thank you.